So we've got three types of motion graphs. We have a position time graph, a velocity time graph, and acceleration time graph. A position time graph, your slope is going to be your velocity, right? Because your slope is your rise over run, and your rise on a position time graph is your meters, and your run on a position time graph is your time, right? This should be time if they were doing this right, and this would be distance. This is a bad graph maker. I could say that I didn't make it. Um, and so we've got meters over seconds. So that's a velocity. So our position time graph, the slope is going to be a velocity. So right here we have a positive slope. So that means our velocity is positive. Right? It's constant, but it's positive. Here, our velocity is 0. And what does it mean when your velocity is 0? Right? It means that you're not moving. So right here, they're stopped. So you could make a graph of this like while you're driving. Well, don't make it while you're driving, but you could make a graph of yourself, like your motion while you're driving. And this would be like stopped at a stoplight or something. And this would be a negative velocity. So you could say that like this beginning was you driving to school, and then your car was stopped all day at school, and then your negative velocity, you like went back home towards your home, but you didn't stop at your house. You went to go. This is obviously pre-pandemic. You went and you went to your friend's house instead, um, and so that's you're traveling the way you came home, or the way you came at the beginning of the day, but you just, passed your house and went to your friend's house. So that's kind of how you could um, talk about a velocity or a position time graph. And what's important with this one is we're going to start talking about the area under the graph. And in this one, the area under the graph is not useful. It doesn't mean anything. So I like to say that we start with a position time graph, and then we go to a velocity time graph, right? Because it's just like a position is like it feels like the graphs are getting more complicated, if that makes sense. We're getting to a more complicated unit, because position was just meters, then velocity is meters per second, and then we'll do an acceleration time graph, which is meters per second squared. Um, and so in this one, the slope is important and the area under the graph is important. So for this one, the slope is rise over run again, right? So it's meters per second over seconds, right? Which would mean you have another second, which would be meters per second squared, which is our units of acceleration. So our slope is acceleration. So here, our acceleration is 0. Okay. So that doesn't mean that we're not moving, right? It means that we're moving at a constant speed or constant velocity. So this would be like, if you had the cruise control on in your car or something like that. And then this means that you have an acceleration and your acceleration is negative. Okay, so what does a negative acceleration mean when, like, if we were doing our car example? It can mean a couple of things. It can mean that you were backing up your car. So you were driving your car, but like backing up, like backing into a parking space or something. That's a negative acceleration. Or it could be like you're slowing down, like this is a stoplight. You know, if this is a stoplight right here, then you're slowing down till you reach stop at your stoplight. Um, and so that's kind of what a negative acceleration. It's either slowing down or going backwards. Okay. And so it's not driving backwards, it's backing up. So like your car's in reverse. Okay. And then the area under a velocity time graph is going to give you your displacement. And just as a heads up, when you get to the quiz, there's like a motion graphs quiz. It's going to ask you to calculate the area under a velocity time graph, and it's also going to ask you to do that. That's one of the short answer questions on your test is calculating the area under one of these graphs. So just For this one, you would do like a length times height, because it's a rectangle for the red, and then for this one, you do like 1/2 base times height, I think is a triangle formula. So that's kind of how you'd solve that. And then if you wanted the area under this entire curve, you would just add these two together. But you just make them into like shapes like this. You don't have to do like this weird, the actual shape of, this whole shape of the graph. You don't have to do that. You just make the rectangle and make the triangle. Okay. Now, an acceleration time graph, the slope for this is not useful. There's nothing that is meters per second cubed. That's not a thing. So it's not useful. But the area under the graph is your change in velocity. Um, okay, so this would be your change in velocity. So you could see that like this right here, that area is a negative, right? Because it's the height of this triangle is -2. So that would be a negative change in velocity. So that might be like slowing down or something, um, or a negative velocity. Okay. So that's kind of that like you've got a positive at the top and below is negative. So for example, if we call these A, B, and C, we'd have like A plus B minus C. That would be our total if we wanted to add them all up. So that's basically what I wanted to show you guys. I know I went a little over your 30 minutes, but